Today we are presenting our Tetris game program that we developed in Visual Studio Code. We built a classic puzzle games from scratch, only using vanilla JavaScript, HTML, no frameworks or external libraries. Let me show you our development environment. Here is our project. In Visual Studio Code, as you can see, we have a simple, clean structure in just one HTML file containing all our game code. We used VS Code's live server extensions to run and test the game during development. Our tech stack is intentionally minimal. HTML for structure, CSS for styling, JavaScript for the game logic, and Canvas AI for rendering. And we also used live server of VS Code for development. When we run the file with live server, it opens in the browser and we can play immediately. Now let me demonstrate the gameplay. The controls are simple. Left and right arrows move the piece horizontally. Up arrow rotates the piece. Down arrow makes it drop faster. The game features all 7 classic Tetris pieces, each with its unique color: the cyan I piece, yellow O piece, purple T piece, green S piece, red Z piece, orange L piece, and blue I piece. When you complete the horizontal line, it clears automatically, and everything above drops down. The game ends when pieces stack to the top. Now I will let my friend Karin continue.
So now I will take you through the technical architecture that makes this game work. I will explain the code. At the first, we will just go to the playfield section, which is in here. Yes, it's in here. So this playfield, it's a 10 column by 20 row grid represented as a 2D array in JavaScript. Each cell holds either a 0 for empty or the name of a tetromino if that space is occupied. So we also have a loop for the game. This is the loop that we created for the game. So in this loop, we have the game loop runs using the request animation frame. This request animation frame is used for running, giving us smooth 60 frames per second animation. Also, in every 35 frames, the active place automatically drops out, drops one row down, as we can see in this code. After that, we're just going to the generate sequence function. This generates a sequence function. Yes, it's in here. And it's used we have some collision detection, which is crucial for the gameplay. So our isValidMove function checks 3 conditions in here. We have a isValidMove that checks 3 conditions. Is the piece within horizontal bounds? Is it within vertical bounds? And would it overlap with pieces already placed? So if any condition fails, the move is rejected, as we can see. And also, we will go to the function with annotation, which is also in the isValidMove, as we can see in here. We also have add event listener, and we also have another concept, which is the rotate function, which is in here. And this core algorithm form the foundation of the game.
Thanks, Karin. Let me walk you through how we implemented these algorithms and the challenges we overcame. We chose HTML5 canvas for rendering because it offers direct pixel manipulation and excellent performance. Each grid cell is 32 by 32 pixels. We draw each piece as a colored square, but make it 1 pixel smaller than the grid to create the clean grid line effect you see. So This is the canvas line, and for the setting up the grid scale line, this is the setting up the grid scale, and for applying the 1 pixel gap on the playfield is the 238 line. And for applying 1 pixel gap on active pieces, this, and each tetromino has its own distinct color defined in our colors object. Cyan for I, yellow for O, purple for T, and so on. This makes piece instantly recognizable during gameplay. This is the lines. And for setting the fill style dynamically, so for line cleaning, here for line cleaning implementation, we scan from bottom to top. When we find a complete row, we shift every row above it down by 1 position. This creates that satisfying cascading effect. And for collision detection and the technical challenges and solutions, during the development we encountered several interesting challenges that required creative problem solving. For the collision detection near walls and piece, first, collision detection near the walls. When a piece rotates near the edge, we had to ensure it doesn't clip through the boundary or rotate into occupied spaces. We solved this by checking validity before committing any rotation or movement. So this is the validation helper function lines, and for the validation before moving or rotating lines, this is the validation before moving or rotating lines. And for the this one also. And for detecting game over conditions, third, detecting game over conditions. Let me walk you through the line. Third, detecting game over condition. A piece can technically exist above the visible playfield while falling. We had to check if any part of a placed piece remains above row 0. That signals game over. And for freezing the game, and this is the outbound row intercept. And for the freezing game and displaying text lines, let me walk you through it. This is the line. for freezing the game and displaying text. Finally, we spent time fine-tuning the fall speed, 35 frames per drop to match the classic Tetris feel. Too fast feels unfair and frustrating. Too slow feels boring. We tested extensively to find that sweet spot. This is the frame delay filter.
Now let me show the final product running in the browser, launched directly from our VS Code workspace. When we right-click and select it Open with Live Server, our game launched instantly in the browser. This is how we have been testing and playing throughout development. Now let me give you a complete gameplay demonstration. You can see the smooth piece movement rotating to fit tight space. There's a line clear pieces cascading down, building strategies, stacks, trying to survive as the pieces fall faster. While we are proud of what we have been, we already have ideas for version 2.0. If we continue development in VS Code, we had added first a scrolling system, second a next piece preview panel, which is show upcoming pieces to players can plan ahead. Third, a hard drop feature, press spacebar to instantly place pieces at the bottom. Fourth, high score persistences. And fifth, mobile touch controls and responsive design for phone screens. Building this game from scratch teach us that game development combines mathematics, logic, problem solving, and creating design. Thank you for watching our presentation.